Okay, hello everyone. Good morning, good afternoon, good evening, wherever you are. Myself, Harsh Soni, moderator of this session. Dear authors and invited guests, welcome to Technical Session 3C. On behalf of Global Knowledge Research Foundation, it's my great pleasure to welcome you all to the International Congress on Information and Communication Technology. This eighth edition of this conference is organized in the hybrid mode. The physical mode is already ended. It's held on 20th February and 21st February in London, and our digital mode is today and tomorrow. So I hope you will all enjoy the knowledgeable and interactive sessions today. Okay. There's a special note for the presenters that in this session we have six presentation, and each presentation will be given 12 minutes for the presentation and 3 minutes for the question and answers. On 10 minutes, I will raise a gentle reminder to conclude your presentation. And there's another request to the presenters that you may all please stay with us till the closing remarks. And if you have any query or any update, you can write it in the chat box. Just before we get started, I would like to introduce you all to the chair for this session. Dr. Tita Bon Ganokrantana. I'm sorry for the wrong pronunciation if I have done. Okay. And there's one another session chair that we have, Doc, Dr. Nilesh Modi. Just want to give some short intro about our session chair. Just a second. If I talk about Dr. Nilesh Modi is having a rich experience of around 17 years in academics and IT industry. Presently, he is working as a professor and director at School of Computer Science, controller of examination, and NAC coordinator at Dr. Babasaheb Ambedkar Open University, Ahmedabad. He is holding a doctorate in e-security at computer science and application. He is holding expertise on cybersecurity and certification on an ethical hacking. He is also have serving as a member of board of studies and selection committee in Gujarat Technological University, Bhavnagar University, along with different universities in the country. And if I talk about Dr. Sidabon, she's received the BSc degree in media technology from the King Mongkut University of Technology, Thonburi, Bangkok, Thailand, and a master's engineering degree in electrical engineering from uh, Chulalongkorn University, Bangkok. Research interests include computer vision and machine learning, specifically human-computer interaction for surveillance videos. She is serving as the president of IEEE HKN Mu Theda chapter. Thank you, ma'am, and thank you, sir, for your presence over here.
Thank you so
Okay,
much.
now I would like, yes, ma'am. Now I'd like to start with the papers. Our first presenter is Adolfo, and he is presenting on a new architecture for. Second. Okay. He's presenting on a new architecture for diabetes prediction using data mining, deep learning, and assemble algorithms. Dear presenter, you may please start your presentation.
Okay, good. I'm gonna share screen. Okay, so to start, I am Adolfo Jara Gavilanes. Good afternoon, everyone. I am a computer science engineer from Universidad Politécnica Salesiana in Ecuador. I'm also a member of the research group called JATA, and I'm here to present the following paper: a new architecture for diabetes prediction using data mining, deep learning, and ensemble algorithms. So I'm in the behalf of the part of my other teammates too, Romel Avila Faikan and Remigio Hurtado Ortiz. So to start, I will want to talk a little bit about diabetes. So normally diabetes is diagnosed in two different ways. The first one is when the insulin is not properly used by the body, or when the insulin when the body doesn't produce enough insulin. So just to have an idea, the insulin is in charge in the body to bring glucose to the cells, so therefore we can have energy. So some common facts about diabetes nowadays is that 1.5 million deaths worldwide. Then there are 422 million people that are affected by this disease. And also in Latin America, 40 to 50% of patients from diabetes get a late diagnosis. I wanna highlight the last statistic, because if we get a delayed diagnosis, we can have serious effects. So now we're gonna talk about them. So the first one is propensity to heart attacks. So as we know, the main cause of deaths worldwide are the heart attacks. So this is a big problem, a big health problem. Then we got the loss of nerves in the limbs of the body. This is the main cause for limb amputation. And as we know, amputation is related to many mental diseases. And then we got blindness, which will affect definitely the state of a patient too. So now that we talk a little bit about the diabetes and some common effects from a delayed detection, I'm going to talk about the goal of the article. So the goal of our article was to create an analysis method capable of predicting diabetes with a great accuracy, precision, and recall. Recall is also called sensitivity in the medicine area. So to start, we're going to describe a little bit about the data set that we work on. And the name of the data set was diabetes data set. This was a public data set that can be found in PayGo too. So to start, it got 2,000 patients, where 40% of the patients have diabetes and the 60% didn't have diabetes. So the variables of the data set were the following ones. First, we have pregnancy. So this was the pregnancy status. So if it was a man, obviously it would be a 0. But if you are a woman, you have a child, it will be 1. If you have 2, there will be 2. Then we got the glucose levels, then the blood pressure, then the skin thickness, which was measured in the arm, then the insulin levels, the BMI, which is inclusion biomarker series, which primarily affects men. Especially, this is a disease that affects the muscular energy of a man. Then we got the diabetes pedigree function, which is a function based on the history of the familiar that has diabetes. So if you have diabetes and your grandparent has diabetes, you will have a higher outcome based on this function. Then we got the age, and finally the outcome, which the outcome will be a binary variable because it will be 0 if you don't have diabetes and 1 if you have. Then we apply the following methodology. So the first big step is data pre-processing. And as we can see, it is in charge of loading the data. Then we got a variable analysis, then noise removal, and variable transformation. Then we apply an exploratory data analysis, then predictive analysis, where we use 3 different classifiers. The first one was an artificial neural network. Then we got a random forest, and finally an AdaBust. And finally, we interpret all the results. So now we're gonna describe and interpret the results from each step. First, from data pre-processing. So once we load the data and we analyze the data set, there were some empty data. So just to not delete those rows of data, we replaced those empty data with the average of the variable. There are other techniques too that can be applied here, but we decide to go for that one. And also the variables were transformed. What I mean with that is that I scaled all the variables. So we apply a min-max scaler. So we will get all the variables between 0 and 1. Then we apply an exploratory data analysis, and the most remarkable part of this is that, as we can see, the glucose, the BMI, and the diabetes pedigree function are the most related one with the outcome. So it means that if you have a high glucose levels, a high BMI, and a high diabetes pedigree function, you will be more likely to have diabetes. Then we apply the classifiers, and as we can see, those were the results that we got. So for the artificial neural network, we got 86% accuracy, 89% precision, and 85% recall. Then we got, for the database model, we got 100% for accuracy, precision, and recall. And then we got the random forest, which got 98% accuracy, 100% precision, and 97% recall. So as we can see, the database was definitely the best classifier among these three. And then we decide to explore which variables were the more important ones for the database to when creating the decision trees. So as we can see, the variables are diabetes pedigree function, glucose, and BMI, which I will remind you that those variables are the three same ones as the exploratory data analysis that we got. Of course, they are in different order. In this case, diabetes pedigree function is the most important one. And in the exploratory data analysis, it was glucose. Then we apply a multidimensional scaling technique just to check how the data was distributed. And as we can see, the zeros is people who is healthy and 1 people who got diabetes diagnosed. And as we can see, many points are overlapping each other. So this was not an easy task to separate the data points. And also for the classifiers, this was not easy too. So applying the method that we got, we can see that it really helped the classifiers. In conclusion of this work, we can say that we reached the proposed goal, because applying the method and applying specifically a database model, we reached 100% accuracy, precision, and recall. But there was a potential limitation, which could be that there was bias based on location, because the data was probably gathered from just one location. So we cannot really generalize this method. So for future work, we propose the following lines. First of all is to gather data from other locations too, so we can create a more generalized methods for predicting diabetes and get an early diagnosis. And also to apply an oversample technique in case you want to work with the same dataset, because as we can saw, it was 40% people with diabetes and 60% healthy patients. So it will be awesome to apply an oversample technique to have a 50-50%. And also it will be cool to apply other classifiers like the XGBoost or the CATBoost. Thank you, everyone. This was my presentation for the paper. Does anyone have any questions?
Ma'am.
Yeah, okay. Oh, okay. So thank you for your presentation. Okay, so
You're welcome.
I was wondering about like why did you get like 100%, like there is no error at all, or like I just wondering because like is like when we test in the real data set like this, so it's hard to get like a 100%. Yeah.
Yeah, I get your question. Yeah, definitely. Probably this was because we divide the dataset. So the best partition for the dataset to get 100% in the database model was 85% for training and 15% for testing. So probably there could be not a bias, but there would be probably like it was too easy, just 15% for training, for testing, sorry. So probably that was the case why we got 100% in the Adabos model.
And why did you choose these three techniques, by the way?
Good question. So first of all, an artificial neural network, because probably everyone thinks AI is the best, AI is the best applying every case, but as we can see, it doesn't always get the best results. So that's the reason we apply some ensemble techniques like the Adabos, which is bagging. I think it's bagging, and random forest, which is a boosting technique. So we wanted to compare the ensemble techniques with an AI technique.
Yeah, I see. I think it would be like clearer if you add like the limitation for each technique, like maybe in your next like future work as well, like if you highlight the strengths and the weaknesses of each technique that you compare, like this one.
Okay, so yeah, that's a good idea, because as we can see, probably decision trees are, for decision trees in this case, it was easier to classify in not neurons. So yeah, that's a good idea to apply.
Yeah.
Thank you for the idea.
Okay.
Yeah, hi. Can you please tell me what sort of data sets you have used? Because I mean, even I'm wondering, in accuracy, precision, and recall, you got 100% result. So, what sort of data set you have used?
Can you repeat the question, please?
Yeah, can you please tell me what sort of data sets you have used in your experiment? Yeah,
So,
from where did you find this data set?
so this dataset was gathered from Kaggle. It was a public dataset.
I'm not getting you.
So the question is, where does the dataset come
Means,
from?
can I know the source of data sets?
Oh yes, of course. Definitely, I use a public dataset from Kaggle, but there are many ones among there. So it will be very nice to join some datasets to have more data. So we will have.
What sort of experiment and algorithm you have applied? Can you please tell me something about the practical experiment that you have applied in your data?
The practical experiment?
Have you carried out any practical experiment, or what sort of tool you have used?
What? Can you repeat, please?
What sort of tools you have used to fetch this result set?
Okay, I get you. So pretty much all of this was made in Python. So for example, we use the.
I want to know about the algorithm. Actual algorithm you have applied.
The algorithm?
Actual algorithm you have applied.
So we apply the three classifiers that you saw. Artificial neural network.
I want to know the actual means practical things that you have carried out on the data sets, because I'm very much wondered that how can you get the 100% result in almost all the accuracy, precision, recall, precision, and different sets.
So yeah, that was just what I answered before. So it was probably was the partition of the data set. First of all, it's not a lot of data, it's just 2,000 patients. And we
Okay, fine. That's it from my side.
Okay. Thank you, sir, for your and thank you, dear participant, for your great presentation over here. And now I would like to invite our next presenter, James Flores, and he's presenting on epidemiological SIS malware spreading model based on Markov chains for IoT networks.
Hi, thank you for your introduction. Give me a second. I cannot screen share.
Okay, just a second. Yes. Now you can share your screen, please, sir. Okay.
Yeah, thank you. Okay, now you should be able to see my presentation. I'm Jose Flores, and I'm going to present a paper called An Epidemiological Sys Malware Spreading Model Based on Markov Chains for IoT Networks. And I'm on behalf of the Systems and Computer Engineering Department from the Universidad de los Andes, Colombia. Okay, so first I'm going to show you the context and the problem of the that we want to model. And then we'll show you what's the model we defined, then some of our results, and finally some conclusions. First, well, we see that the amount of Internet of Things devices has increased in the last few years by a lot. And it's projected that the number of these devices will keep increasing as time goes on for the following years. Then what's the problem? The problem is that these devices do not have defined all the security protocols that a lot of usual like the usual computers have. So one of the first inspirations or malware that we based this work on was the Mirai malware. This malware takes control of IoT devices and uses it to do DDoS attacks over some victim or some servers. And this malware can spread through a network. What we wanted to do was to model the spread of this malware and detect maybe some metrics or some controls that we could apply to these networks, like to be prepared for a malware attack like Mirai. So we wanted to use an epidemiological model to model this situation. So we used the SIS model. What's the SIS model? The SIS model consists of the susceptible individuals, the infected individuals, an infection rate, and a recovery rate. This is the base SIS model. There's also like SIR model, which takes into account the number of recovered individuals that cannot be infected again. But we used the SIS model because it models this interaction device. When a IoT device gets infected and it recovers, it can be infected again. So we used a SIS model. Then, what we have as an input for our model are the network adjacency matrix. So we have an heterogeneous model that takes into account the network distribution at the adjacency matrix of the network. We have the number of nodes of the network. We want to measure the number of infected nodes on time t. And we have the states of the network. So we want to do an stochastic epidemiological model. So we're modeling a Markov chain. The states of the Markov chain are every possible combination of infected nodes of the network. So a node can be zero is susceptible and 1 is infected. So every node of the network can be in one of these two states. Now we want to define the transition matrix for our model. So as we can see, one state is the combination of states, and it can go to another combination of states. There can be two things happening. A node can be infected, which corresponds to the first case, and an infected node can recover, which corresponds to the second case. In the second case, it's just the recovery rate, and the first case is the infection rate multiplied by all the nodes that on the adjacency matrix point to that to that specific node that's going to be infected. So these two are the possible changes of states. Now, if we define the model this way, we propose an algorithm that can do the following. So first, we can create the Markov chain using the transition matrix of the generator matrix that we define here, which corresponds to the algorithm that you can see on the screen here. It just goes through all the to the end matrix and fills this state with the corresponding equation. Then, after we have defined our Markov chain, we can calculate the time before the infection ends. This is because we have an absorbing Markov chain. With an absorbing Markov chain, the state 0, 0, 0, 0, where every node is not infected, is the absorbing state, because we cannot go to another state when everyone is not infected. The infection ends. So that's the absorbing state. And in this state, we can calculate how many time will it pass before we can go to the absorbing state of the Markov chain. Then we can also calculate the expected number of infected nodes on time t. To do this, we have to define the generator matrix of the Markov chain. Then we go to the probability matrix, which is just taking the exponential of this matrix for a defined time. And we can calculate how many nodes are expected to be infected on time t. And finally, using the previous calculations, we can show which is the most critical node of the network. So to corroborate our algorithm, we compared it with the Gilles-Piez's algorithm, which is just a simulation algorithm to simulate this phenomenon. We buried the parameters of the model in the Gilles-Piez algorithm. We buried the time, the adjacency matrix, the number of samples of the algorithm, and we compared it with our like pure Markov chain model. And we did a t-student test to compare the distribution of both models, of the result of both models, to get a and got a p-value for each variation of the parameters. And as we can see, the p-value is extremely low for each one of the models. So we can safely say that our model predicts correctly like this metric that we define here, the critical node, the expected number of infected nodes, and the time before the infection ends. Finally, these are the visualizations of our model. Here we can see if a node gets infected first. For example, if this is a 5-node network, if one of the, for example, if the second node gets infected first, then the infection would be not as bad. As we can see, is the lowest time before the lowest number of infected nodes at the beginning. But if we get like the 4th node or the 1st node infected, the number of infected nodes is going to be higher. The second visualization is the expected time until the infection ends. And as I said, we can see if one of the nodes gets infected first, how long is the infection going to last? Finally, using these results, we can take the one that produces the highest amount of time until the infection ends, and that's going to be the critical node of the network that we can see here. So this is an example of a network distribution. And as we can see in the previous graph, the sixth node, if that node gets infected first, is going to be the critical node of the network because the amount of time before the infection dies is going to be the highest. Yeah, so these are the three main things that our model allows us to predict. In short, what are the conclusions of our model? Well, we made a Markov chain-based algorithm to analyze a network, predict the number of infected nodes, and to see how long would the infection last and what's the most critical node of the network. Then our algorithm can analyze like heterogeneous networks, which means networks that are not everyone connected with everyone. And can allow us to analyze the distribution of every possible state with its probability. Then, as we saw earlier, we compare this algorithm with the GGSP simulation algorithm with varying the parameters, and we had as a result low p-values, which helped validate our algorithm. Finally, this proposed algorithm is an exact stochastic solution, but one of its drawbacks is that it has to take into account every possible combination of states of the network. And as we saw earlier, this means that we have 2 to the n states, where n is the number of nodes of the network. This means that the generator matrix of the Markov chains is going to be of size 2 to the n times 2 to the n. So we propose as a future work that we may be able to use an approximation algorithm or some kind of heuristic that doesn't need to have 2 to the n matrix of 2 to the n times 2 to the n, which means that the performance of our model is exponential. So a proposal would be to use an approximation algorithm that doesn't have to take into account every possible state. So that would be our presentation. So I don't know if you have any questions.
No question from my side.
Okay. Ma'am, from your side, if you have any question, you can ask him.
Okay. So very nice presentation. By the way, I have a question like about your data. I want to know like how many states that you have in your data.
Oh, okay. For our tests, we varied the size of the adjacency matrix from 10 nodes until 26 nodes, which is rather big for our model because it will mean that the number of states is 2 to the 26. Yeah, for our validations, the biggest network we took had 26 nodes.
I see. And do you face any problem? Like it is too complicated or like?
Yes, it actually takes a lot of time when the network is big, because as I said, the model grows exponentially.
And what do you think, like, if you want to improve this work in the future?
Yeah, like we probably could use an approximation model, maybe something like the NIMFA epidemiological model that doesn't take into account every possible combination, which wouldn't give the exact solution, but it would take a lot less time.
Okay, may I know like how long that you take for this one to learn?
It took like for a 26 nodes network, it took like an hour,
An
2
hour?
hours.
2 hours. What's your spec? Like you use TPU or
Yes, here in the paper we used a let me check. Okay, we used a computer with 32 gigabytes of RAM and an E5 86K CPU with 3.6 gigahertz of speed. That's what we used.
okay, okay. Okay, that's all. Thank you for your presentation. Yeah. Keep up
Okay,
the good
thank
work.
you. Okay, thank you.
Thank you, dear presenter, for your presentation.
Okay, thank
Okay,
you.
so now I would like to invite our next presenter. Our next presenter is Sangmi Mun, and she is presenting the concept of electronic chip electronic record book system based on ISO 21745. Dear presenter, I think so she is not available in the session. Okay, we'll move forward for next presenter. Okay, so our next presenter is Gauri, and she is presenting on student alternativeness classification using geometric moments aided posture estimation.
Hello,
Yes, hello, ma'am.
I'll start sharing my screen.
Okay.
Good evening, everyone. I'm Gauri. Today, I will be presenting my paper on student attentiveness classification using geometric moments aided posture estimation. Traditional ways of measuring student engagement is using questionnaires and surveys. This is not real time as it takes a lot of effort to gather all the surveys, interview the parties involved, and analyze all the data collected and create a feedback report. To overcome this drawback, a computer vision method to solve this using posture information is proposed in this paper. The novelty of this method lies in the way the pose features are extracted using geometric moments of a region. There are different behavioral features that can be used to work with this computer vision aided feedback system. They are face features, head pose or orientation feature, eye gaze direction, body posture or action feature. Today, we will be talking more about the body posture feature. There are different approaches in which body posture has been used to identify the attentiveness of the students. First one is this, where they've used location of wrist key points and distance between nose and neck key points to see the frequency in which these key point locations are changing and identify the attentiveness, which eventually using the movement factor. And in another research, they've carried out an extensive research to identify what are the postures that help in identifying the attentiveness. And they concluded that postures such as taking notes, raising hand, etc., help in identifying the attentiveness of the student accurately. And so we decided to go with only the upper body key points after reading about this research. And in another set of researchers where they've tried to classify the postures, they used media pipe to extract key points, and the extracted key points were converted into a skeleton image with black background, which was then used with deep learning algorithms such as CNN or LSTM for classification of these images. This approach is very feasible when it is a single person post-classification application with no fast movements, for example, yoga posture classification. But it was not very feasible for a multi-person and real-time application such as the one that is intended. So for that, we explored another approach where they used the distances and angles between these key points as features for classification. They classified up to 4 postures and used YOLO V4 for person detection. This was computationally inexpensive and performed well with over 90% accuracy. To summarize, the different approaches of body posture feature for classification are considered, and the one proposed by Lin was very accurate, which was using distances and angle features to classify. On the similar grounds, a novel method of using geometric moments of a region as feature for classification is proposed. And the entire system that is proposed for attentiveness classification will be discussed in further slides. So the video, the classroom video is processed in frames, and for each frame, object detection is carried out first to identify the students. For each student, using media pipe and geometric moment aided feature extraction, those features are extracted. For all the features that are extracted, posture is classified, and these classified postures are then aggregated and a statistical report is generated. First step is object detection. 3 different object detection methods were implemented and compared. First one was histogram of oriented gradients. This does not use high computational power compared to the deep learning approaches, but it fails to detect the bounding box of the entire person present. YOLO V3 is a very fast algorithm and has accurate results, but a part of the person is not present inside the bounding box that is detected. RetinaNet was another object detection algorithm that was used, which was both accurate in terms of identifying the localization of the person and identifying the bounding box around the person. Only problem was it was slightly slower than YOLO V3. This is a sample comparison between the 3 different object detection algorithms. As we can see visually, that RetinaNet is a choice, is the choice we went with. The next step is post feature extraction. Using media pipe, posture key points are located. Key points are basically 2D or 3D coordinate location of a key point in the image. Key points such as elbow, wrist, shoulder, etc. And here we'll be considering only the upper body key points. And 2 different ways of extracting these necessary information are carried out. First one is the distances angles method, which is similar to the one proposed by Lin, and the novel method, which is using region features or region properties as features for the classification. First, the distances and angles method is pretty straightforward, where distances between all the key points are considered. This is what is used widely in most of the researches, and angles as well. Angles formed by shoulder, elbow, etc. Area of triangle is an extension where area formed by 3 key points as a triangle is considered to see how close each of those key points are. To give an overview on geometric moments is the weighted average of the image pixels in each region or object. Image moments help in gathering simple properties of the region, such as area, centroid, orientation, etc. Interested area is enclosed in an ellipse in our case, and the properties of these ellipses are used to identify the posture. Major axis length of this ellipse is like the length of the principal axis of the region. Angle of orientation of the principal axis is the angle of orientation of the region. Center of ellipse is the centroid of the region, and area of the ellipse is m00th moment of the region in terms of image moments, which is given by this formula. To give more information, the posture that is presented is first divided into 5 different regions. As we can see here, 5 different ellipses, which is a body region, left and right forearms and arms. For each of these regions, 5 different property features are extracted. They are center coordinates, center of each region coordinates, which is relative to the body center when it comes to other regions, and the length of the central axis, angle of orientation of the region, and area of the region, area that is present, area of the ellipse, basically. So then after extracting the feature, the next step is post-classification. 3 different classifiers, KNN, SVM, and random forest classifier were used to check the best performing classifier. And all the features that were extracted were stored in a .csv file, and the feature space was normalized before subjecting it to either of the classifiers. And for KNN, K is set to 3, which means it looks for 3 neighbors class for classification. SVM uses a linear kernel, and random forest uses up to 100 n estimators. KNN seems to be a perfect fit in terms of theory, but the only problem was it does not function well with high dimensional data. Since we had about 25 features that we extracted, it did not perform very well. Support vector machines can handle high dimensional data and classify better even with a small training set, but it fails when there are overlapping classes. Random forest classifier can handle high dimensional data and make sure the classifier does not overfit, but it takes more time to train the random forest classifier, which is why random forest classifier was used for further classification, because it had the least amount of trade-off. After classification of each posture is grouped into an attentive state as presented in this table. These are the sample images that were used for training. And to compare the accuracy of both the methods that were considered and all the classifiers, this table shows that the novel method proposed consistently performs better than the distances and angles method that was used by Lin. And we can see that random forest classifier performs really well compared to the other 2 classifiers. These were the object detection results using RetinaNet. This is a frame from a video, classroom video. This is another image, a frame from a classroom video where each person's posture is classified. Even father person posture is classified, and confidence with which it is classified is also mentioned. Although some of them are not completely accurate, it does try to classify to the closest possible posture that can be found. This is the result that is presented to the user towards the end of the system, which is a statistical report on the percent of students having either of the 4 attentive states. And it also presents information on what was the posture that was mostly found, and similar and such statistics. Contribution. So the contribution of this paper lies in the way the features from the key points are extracted. We used a novel method of using of geometric moments of a region to classify, to gather the proposed features and classify them. The proposed method of geometric moments is implemented, and it shows that it performs with 92.4% accuracy. Future scope. Improvements can be both in terms of methodology and experiment. Experiment can be improved by using different types of classrooms, different density classroom for testing, and using different quality cameras, using programmable cameras. And in terms of methodology, adding action recognition and movement tracking will help in enhancing the classification accuracy. Classification will make the classification better. These are my references, and thank you. Any questions?
Yes, sir. Do we have any question for presenter? Ma'am, do you have any question?
Okay, so I have just few questions. And
Mhm.
thank you for your presentation. Like you present in like give the audience more detail on your work. Very nice.
Thank you.
And I just wonder, like for the conclusion, so you choose RetinaNet as the object detector,
Yes.
right? And
Yes.
for the classifier, you choose random forest.
Yes.
Okay, I see. Maybe you can, like when you conclude your work, you can
Okay.
wrap up again, like what is your finalized. Okay, yeah, that's cool. Okay. And I wonder about the like how many gesture that you can detect right now.
There are 10 different postures that I've listed here. 10 different postures and 4 different attentive states. I do have same amount of data for all the classes that are mentioned here. I used data augmentation to make sure all of them have the same amount of data, which is 100 images for each class. And I trained my classifier with the data that I have.
And for the data you collect by yourself?
Yes.
I see. Like how many frames that you have collected?
So I collected around, I would say on an average 50 for each class, such as
50.
hand raised, hand crossed, etc. And I augmented that to be around 100 for each of them.
I see. Yeah. Okay, so I think you should also add that information as well for the data set.
Okay, I should have. I just.
Okay, yeah, I have only these questions. Okay, thank you for your presentation.
Thank you.
Okay, thank you, dear presenter, for your valuable and great presentation.
Thank you.
Now, I'd like to invite our next presenter. Our next presenter is Lee, and she's presenting on a study on the collective. Just a second. She's presenting on a study on the collective behaviors of topologically interacting neighbors in network theory.
Hello, good evening. This is Richard Chen, a mentor of Hyunsu Lee. On behalf of her, I would like to present a paper titled The Study on Collective Behaviors. I'm sorry, I have to share my screen first, right? Sorry about that.
Yes, you have.
Share screen and desktop, share. I have shared my screen. Would you please confirm?
Yes, it is visible, sir. Please make it full screen and you can
Okay.
start your presentation.
Okay. So the research title topic is on graphing theory or network theory, titled by study on collective behaviors topologically interacting neighbors using graphing theory. Before I present, I would like to ask your understanding, because this research has been done by a student, one of my students who is attending international high school. And the level of the study is about in the middle of like high school and undergraduate student level. So it might be easy to some of you. So I'd like to ask your understanding. But I would say that she will try to her best to understand the concepts and the procedures and try to coding some parts using the MATLAB programming and so. As Jose reviewed the concept of this theory, this study uses consensus dynamics of graphing theory, and that applies to like many situations like engineering and social status and economic things, and as well as like physics and other sciences. So this time we wanted to focus on social networks on time scales, and that is specifically applied to specific communities composed of multiple decision-making agents. So taking an example for simple diagram like this, we wanted to extend this kind of knowledge to a little more complicated random cases of social structures like this, figure 8. The basic concepts is using adjacency matrix and like Laplacian, which is the relation of the Laplacian and the adjacency matrix is like L equal D minus A. So L is the Laplacian matrix and D is diagonal matrix and A is the adjacency matrix. The relation between those are L and other the major governing equation is like expressed in terms of first order of equations like this. And the reason we use this theory is because there are much of the advantages of the flexibility, simplicity, and tractability. So for example, the consensus presents a model for opinion, forming the lot of different individuals in the society. Also in engineering analysis, there are many engineering like electronic engineering, there are many blocks, building blocks. You can separate into different building blocks and you can merge them into one to see how the whole average responses will be like. So basic theory is using the Cauchy-Green circuit theory. Let me make it fit in my. Basic theory is finding a matrix for given structures or communities, or which could be the matrix of L and A, which is Laplacian matrix and adjacent matrix, and finding the eigenvalues. Eigenvalues in this case can be some opinions of individuals, or could be frequencies of the mechanical structure, or like temperatures and heat conduction, whatever it is. So this study will be the basic to extend it to in many cases like medicine, engineering, and other different scientific areas. And I'd like to skip all the basic equations. Again, the dominant governing equation is first order equation composed of this L matrix and other stuff. There are some like initial value conditions. And finally, when you solve those kind of the equation, the network theory based on the situations, the social status of phenomenon, the equations are expressed in terms of this. And if you solve the equation, they could be expressed in terms of like time, function of time, which is if you add up all the initial inputs, opinions, like initial temperatures or loading forces, whatever it is, then the response could be the average of those all inputs, number of n inputs. So which that makes sense, which is making sense. Again, the basic, the concepts of Laplacian adjacent matrix has been used. And she tried to figure out how the time scale differences are occurring in different situations. So we tried using the first example using 6 nodes in this case, but different connections like this. And eigenvalues are expressed in marked in like a red dots here. So because there are 6 nodes, we found the 6 eigenvalues, which is spread apart. And connectivity finding the connectivity and node conditions. We can find the responses, final responses are converging to 0, but the inputs are all different. 6 inputs are different in this case. And the different topology and geometry could give us a little bit different, like the shapes of the converging the time and converging shapes like this. So for example, this one, I think is kind of this group and this group is kind of too farther away from each other. So their convergence of opinions, communications cannot be the same as this one. This one is a little more close to each other. So there will be convergence of opinions, communications, responses will be a little faster. So x-axis is kind of time. And y-axis is kind of the inputs, the number of inputs and the strength of the inputs. So this one, the converging time could be a little like slower than this, which have to make sense. But this one, topologically, with the same nodes, topologically different, having more like communications, and there are less eigenvalues, only 2 dots, like red dots. So we should find that there are some relations between like a number of connections and number of eigenvalues. Eigenvalues in this case is responses to the inputs in this case. So in this case, it's very dense, means communicating are occurring very actively. So the number of the edges are affecting the responses, which is very quick in this case. The others are kind of different situations. And this one is a little similar to this, but still like slower in responses. So. But that case is kind of simple and basic diagram. we wanted to extend a little more practical examples by using the advantages of these like simplicity and flexibility and tractability. So again, the same governing equations, first order differential equation, which is consensus dynamics equation, and extended to a little more general, the practical general situations, which has like a structural adjacency of structures and adding the random the adjacencies.
Sorry to interrupt you, sir, but we have last 2 minutes.
Oh, okay, I see. Yeah, thank you. So this diagram shows a little more complicated, which is a little more practical, which has 1, 2, 3, 4 groups of society. And we can simplify into similar shape, but different nodes, number of nodes, which is proportional to this. And you can find the adjacent matrix like this, which shows like diagonally dominant, which means the numbers other apart from the diagonal is kind of sparse, the 0. And using more like a nodes, edges, number of the individuals, communities. In this case, 3 different blocks, but there are still, we have more like societies around here. It is not clear because it is kind of dot here. And 3 communities shows different colors by different colors like this. And the convergences are like this in this case. And time scale occurs at this point. But if you increase the density of these individuals, like from 0.3 to 0.5, 0.4 to 0.6, it becomes a little different. Time scale becomes a little different. Responses are kind of a little faster. And the average responses are shown here. And using this consensus dynamics, we could find the conversion occurs symmetrically or asymmetrical depending on the topological differences. Thank you very much. Any other questions will be appreciated, but as I am saying, the research itself is not the level of like the students who are attending like a master degree or PhD students like this. It's kind of a little straightforward and easy.
Okay. Okay. So, ma'am, do we have any question for presenter?
Okay, just want to know that what is like your way to to improve the work, or do you have like any other techniques for your future work? Yeah.
Oh, okay. Let's see. To improve, there are many things, because I figured out that she had a problem to construct the metrics for a little more different degree of freedom, like a bigger degree of freedom, using the MATLAB, because it takes a little like energies and time to construct the adjacency metrics, because sometimes it has to be manual. For example, like a 2-dimensional, it's kind of easy, but if you extend to 3-dimensional, it takes a little time and energy, because connection between the nodes and edges, we have to rotate the figures to the right, to the left, and top and bottom to see the connections. So that's why she didn't want to include the 3-dimensional shapes. It is only like 2-dimensional topological shapes. So the future study could be including that kind of 3-dimensional structure, using more like a coding, programming, yeah, to reduce the time and energy.
Mm, I see, I see. Yeah, I think it would be like if you can reduce the time complexity, and yeah, I think it would be
That's
great.
the
Yeah.
major concerns of our research. Thank you very much.
Okay, thank you. Thank you for your presentation.
Okay, thank you, ma'am, for the question. Nilesh sir, do we have any question for the presenter? Okay, so I think so there is no question. Okay, so now I just want to invite our next presenter. Okay, so our next presenter is Leonor Felipe Santos Patricio, and he's going to presenting on the contribution of robotic process automation in improving energy efficiency case study.
Hello. Good afternoon.
Good afternoon.
So, my name is Linal Patricio, and today I present the work about the title, The Contribution of Robotic Process Automation, RPA, in Improving Energy Efficiency case study. Thanks Al for assisting my presentation. Thank you, our first author, Carlos Costa, for assist the presentation. I'm student University do Minho, Portugal, and Carlos is professor, the doctor in Brazil. So, summary, introduction, robotic process automation, RPA, case study results, conclusion, and in final reference. Robotic process automations, or RPA, aims to automate administrative process by software robots, repeating human tasks using a graphical user interface. These types of robots allow the automation of various process works related to the back office that are previously performed by people. Sustainability reveals to companies a paradigm that stands out in negotiations based on social, environment, and economic responsibilities. Since the term business sustainability emerged, more organizations have emerged that bring sustainability to their business, thus improving their economic, environment, and social objectives. As part of the evolution of information technologies, RPA is a technology that is in great growth, and that is why discussions about how to adapt the concept of energy efficiency and the sustainable implementation of RPA become important. The combination of these concepts can be an important aspect to achieve better energy efficiency in an organization. Central research question: how will the implementation of robotic process automation contribute to an improvement in energy efficiency? This work aims to identify the contribution of robotic process automation implementation in improving energy efficiency. In order to achieve the objective of these investigations, a survey of the times of RPA projects was carried out in an administrative department of a company. After this survey, a comparison was made before and after the implementation of the RPA to verify if it was possible to obtain an improvement from an energy point of view. The research methodology applied in this investigation was the case study. So what is RPA, Robotic Process Automation Technology? RPA is a computer technology that allows automating routine tasks, which are normally performed by people automatically and simply, allowing companies to be more efficient in business process. with technology embedded in almost every day-to-day process in a company. It's easy to see advances in computing and technology. In this context, it's important to seek knowledge and adequate measures to reduce expense and live sustainably. So, the case study. The case study present here was raising in the administrative department of the company in Portugal. Robotic process automation technology was implemented in the administrative department in 12 projects that were executed manually. In order to carry out our investigation, a survey was carried out with the robotic process automation team of the department so that it was possible to carry out the energy study after the implementation of the RPA. In the section below, data relating to the 12 projects will be present. Next table, identification of execution times of 12 projects implemented in RPA. In first column, projects lists. Second column, manual run time before RPA implementation, where the process are executed manual for 2 persons. And the end table, software robot runtime with RPA implementations. The next graph is a comparison of execution times in relation to projects implemented in RPA in the administrative department. It's different times, the manual runtime and software runtime, the same process. So the results about investigation. We will now present the calculations related to energy cost for each of the scenarios. Manual process execution time, 300 minutes, and process execution time using RPA technology, 121 minutes. Regarding energy costs, we consider for the purpose of manual execution of the process of the use of 2 portable computers, 4 light bulbs, and 1 AC in use for a total of 300 minutes. The equations for manual process. And let's see that we had expenses in order of 301.9 kWh per month with this device connected. For the 300 minutes, there was a total energy expenditure of 188.69 kWh per month. But in use RPA regarding energy costs, we consider for the purpose of implementing robotic process automation the use of 1 computer server and 1 AC for computer server sales in use for a total of 121 minutes. This is equation for RPA implementation. Let's see that we added expense in order of 382.6 kWh per month with this device connected. For the 121 minutes, there was a total energy expenditure of 84.24 kWh per month. So, conclusion, after the survey, a comparison was made before and after the implementation of the RPA to verify if it was possible to obtain an improvement from the energy point of view. With the results of this work, it was possible to identify that after the implementation of the RPA technology, a reduction in the volume of energy consumed in the order of 78% was equivalent that RPA also executes all process in 40% of the time that the processes are executed manually. As a future work, it was suggested the creation of models with KPIs, key performance indicator, that allow the quantitative financial evolution of the energy efficiency after the implementation of RPA technology in organizations. For this presentation, it is reference, and thank you all. Question, please.
Okay. Okay, is there any questions from the audience? Okay, so maybe I just ask you one question. Okay, so
thank
thank
you.
you. First, thank you for your presentation. I actually don't know much about the survey like this one, like for improving this energy efficiency. So I wonder that if like is there any like a technical algorithm that can can use to improve this RPA? Yeah.
Yes, this study is about comparison manual processes of persons in department administrative in company and comparison about the implementation technology. And if the enterprise implementation this technology RPA exists a good benefits for enterprise. Energy efficiency is one point, and others time and costs for execution process, manual and repetitive tasks about the RPA, our manual process. And this study is very important because in very enterprise in the world, in my enterprise, exists the concept sustainability green or environmental, social, and economic. And RPA is a new technology. And in my investigation, I think in relation about this technology RPA, it's my job with the other concepts importance for major efficiency in organization or departments. And for me, it's very important the in actual and now the environmental and energy. It's a good example.
Okay, I see. Yeah, very nice. So what's your plan for like for your future work?
About this project, this investigation, it's create a model for introducing 10 companies KPIs about sustainable projects. In my PhD, I investigate on system plan optimization, the license for RPA. But in other projects, I create new models. For example, in IT, in IT area, it's normal to use the Scrum Agile methodology. In my other work with Carlos and Lucas and Leonel, uh, I create a new paradigm. Use the methodology, the production, PDCA, plan, do, check, act, in the implementation RPA team in organizations. It's a very good work about this technology. And in the future, I think it's the good works in conference and journals about this technology. That's my plan.
Yeah. Okay, so thank you so much. Yeah, I think you can.
Thank you.
I think you can achieve your plan.
Yeah, thank you.
It's just a matter of time, right?
Yeah.
I see. Yeah, keep up the good work.
Okay, thank you.
Okay. Okay, so I think we have like completed all of the papers, right?
In the moment I write two papers about the RPA technology and the medical health service. With Carlos, Leonel, and Lucas, it's other college about the authors of my first book about RPA. I published in January 2023. And the next phase is, I think, create a new paradigm about the RPA technology and auditory in enterprise. It's the next plan or in final year where I finish my PhD. Another plan is relations the RPA concept and big data. And the other article in my it's ChatGPT and the new technology intelligence artificial with RPA. It's the next plans for my papers. I work with different persons in countries, and it's possible new papers in the next months, but it's a price.
Yeah, that's nice.
Thank you, thank you.
Yeah, you keep like publishing more papers. Yeah.
Yeah.
Yeah. Okay, so is there any like more questions from the audience?
Okay, I think so. There's no question from the audience. And sorry for the inconvenience because of network issues. I got disconnected from the meeting.
I see.
Can I have one question? Quick question.
Yeah,
Yes, please, sir.
That I can access to the full papers available on CD or online?
Sorry, you're
Is there
asking
any-
about the publication, right?
Yeah. But what
Sir, the
papers of others, like presenters today?
Sir, we will upload the video, the recordings of these meetings. I think so in 1 or 2 weeks, and then you can see the recording in the website. And furthermore, the publication will live in 5 to 6 months. So it will take around 5 to 6 months process for the publication, and we'll send you the link about your paper and all.
Okay.
Okay.
So in 2 weeks, I can see the recordings, and in about like 5 to 6 months, I can see the whole publications online.
Yes, please. Yes.
But can I see the other like a publication? I mean, the full papers through online is not accessible.
Yes, you can follow our website. You can, and you can also see the publication that we have followed.
Okay.
All the 7th edition we have uploaded on the website. You can go through that.
Okay. Thank you very much.
Okay. So now wrap up this session. I sincerely thank our authors for their excellent presentation and all the participants for being a part of this international conference. And I hope this session was informative enough. And on behalf of whole team, thank you for your support during this version and the previous 7th version of this conference. And we will be happy to have you all in the 9th version of this conference in 2024. And moreover, all the participants will be getting their digital certificates through email within 2 working days. And the publication will be live within 5 to 6 months. So kindly cooperate with team ICICT 2023 and the Global Knowledge Research Foundation. And just before we end the session, I would like to thank our session chair for chairing the session. Nilesh sir, there is one token of appreciation from the GR Foundation and the team ICICT to chair the session on behalf of them. And ma'am, there's one token of appreciation for you to chair on behalf of team ICICT 2023.
Okay, thank you so much.
Okay, thank you, ma'am. And thank you, sir, for your valuable presence over here. Okay, now in the end, I would like to request you all to turn on your camera so we can capture the good memories of this virtual conference and make this more memorable.
Yeah, this is the moment I'm waiting for.
Yes.
Like in Thailand right now is like 1 1:30 a.m.
Oh, okay. So
Yeah,
it's
and
midnight then.
yeah. Okay, actually, like, it's nice to meet you all, and thank you so much for inviting me to serve as a session chair as well. Yeah. Okay.
Thank you very much.
Okay. So there's two other participants. If you are turn on your camera, it is good for us to capture these virtual memories.
Okay.
Okay, no worries. Take this photo. Okay, thank you so much to all the participants, and thank you and thank you, ma'am, for chairing the session once again.
Thank you.
Okay, thank you so much.
Okay,
you.
everyone, take care and bye bye.
Bye.